whenever you're working with quadratic functions, it's kind of nice to understand what's happening algebraically as well as graphically and putting those both together. So if we have a quadratic function that's usually written in the form of f of x is equal to ax squared plus bx plus c, if we were to graph that, we'd set y equals ax squared plus bx plus c, you're going to get some sort of a parabola with the vertex. Now, you'll notice that if we ever have a quadratic function set equal to 0, you're going to expect, in fact, usually you would factor it into two segments and you'd expect to get two solutions. Now, what's happening graphically, the reason when we have it set equal to 0, all we're saying is that when y is equal to 0, what is our graph looking like? So there's three possibilities for our vertex. Let's say our vertex lies above the x-axis. In that case, we're going to get no solutions, or at least no real solutions. Now, when we get into imaginary numbers, that's when they come into play. Because you're always going to have, with an x squared or a quadratic function, you're always going to have two solutions. In this case, they're imaginary. Now, if our vertex lies below the x-axis, then obviously we're going to have two places that it crosses the x-axis, and that becomes our two solutions. Now, there are times where the vertex lies right on the axis, and in that case, we're only going to have one solution. Normally, they will call it a duplicate solution, and usually because you have it in the form of, let's say we had x minus 3 quantity squared is equal to 0. We get the solution of x equals 3. It just shows up twice. So in either case, we're always going to have two solutions, but they're not always going to show up as real number solutions. But that's what we're looking at. We're looking at graphically where it's crossing the x-axis. Now, if let's say we have a function that is a third degree, meaning we have an x cubed, we would expect to find three solutions. And the reason for that is we no longer have a parabola, we have something that looks like this. And so if we were to put in our x-axis, you're going to have 3 points. Now, obviously, there's going to be times where it only crosses twice or maybe even only crosses once, which means we're going to have imaginary solutions or we'll have duplicate solutions. But for every degree that we increase, we expect that number of solutions. So x to the fourth is going to give us 4 solutions. And in that case, we're just adding another turn onto our graph. And every time we add a degree to our function, it's just adding another curve into our graph. And so we would expect it to cross the x-axis that many times or have duplicate solutions or imaginary solutions. So graphically, that's how it's portrayed and why we look for the number of solutions that we look for whenever we're dealing with functions. Now, if this is helpful to you, please like and subscribe. Always pass this information on to some that might need it. So as you get refreshers, especially as you're getting back into school or you're reviewing information that you need for an upcoming lesson or upcoming topic in your math class, a lot of these are going to be helpful in just refreshing you on what you've done in the past, or maybe just introducing it to you in a slightly different way. So like and subscribe, hit the bell button if you want to get updates on when I've added a new video.